We are now moving to the next report that we will have by video channel. Our colleague from Michigan University, Professor Eugene Levin. I will try to set up communication with him. The title of his presentation is Research in Hands-Free Control of Digital Photogrammetric 3D Measurements. What's hands-free? I have no clue, so we'll all get enlightened now.
Вы нас слышите?
Евгений?
Yes. Can you hear us?
Ты слышишь нас?
Yes. Yes, we can hear you.
Okay, let's start.
Okay, so we are online. Юра?
Я здесь, давай начинаем.
Okay. Hello everybody from Michigan Tech, and I have here with me my students,
Justin Carter, Kevin Takwa, Krishna.
Okay, and we would like to share, okay, it was very interesting to hear about industry, but we want to bring a little bit of research. And so, can you see my PowerPoints right now? Yes? Okay. So, in this presentation, we would like to discuss motivations for our research. We will talk about how to teach photogrammetry and why at all, and by the way, our research about human-computer collaboration, human-computer interfaces. We will show some live demo and results, and we will discuss our future research. So, basically, yeah. Okay. First of all, why we at all doing this kind of research? So we know that in fact we are limited. Any agency or organization is limited by photogrammetry or JS operator, and therefore it's very important to use their time efficiently. And in spite of higher and increasing level of automation, we still have human in the loop. And we believe human will always be in the loop for the simple reason which is mathematically formulated by famous Turing theorem. So Turing was a Hungarian mathematician, and he said that in any branch of mathematics, actually there is something which is behind axioms, and all the machines which we use today, all computers, are Turing machines. And therefore, mathematicians, by the way, have a very good joke saying that there is no logical foundation of mathematics, and Turing proves that. So human always been in the loop. We hope it will be less and less human intervention, but so far at any industry, this is reality. Okay. So here you can see a picture how I teach my photogrammetric labs, and you can see these two gentlemen. What they are doing, they collaborate. So they collaborate in a didactic way. So one of them is measuring some stuff. And usually if I teach somebody to measure, I also use glasses like that, and I show, okay, your measurement is correct, your measurement is incorrect. And this way is collaborative teaching. And if you look to a little bit of history, so we may find that collaboration idea is not very new. This is a picture of a device, analog device called interpretoscope of Carl Zeiss Jena. So what we can see here, we can see two guys, right? Analyst 1 and analyst 2. They're looking on the same data set, and basically they have own visual control of this data set, but they collaborate, they discuss. So they discuss what they consider, they have agreement or they have discrepancy. So this idea is not new. But unfortunately, this opportunity was lost in soft copy photogrammetric in JS environment. So, what kind of typical operations our operators and analysts are performing during this kind of collaborations. So they do zoom in, zoom out, they pan, they measure in 2D or 3D, they select and modify elements and saving good saving results. And finally, what is most important, they discuss. They make conclusion and their collaboration is discussion either. So, how this environment can be realized nowadays? Okay, so let's imagine we have an environment where we have common view for two operators, or let's say teacher and student, and we have some objects where both operators give both as this is structure. Okay, and we have view where they have discrepancy. So what if we will have separate control, one for student, one for instructor, and basically student has control of student view and instructor has control of actually his view. And they see visual logic of each other and they can collaborate. And by the way, Kevin Takala is the guy who developing this system. Kevin, where we are right now in this? Can you bring the idea where we are right now, what you're planning to do?
So far, I'm planning on using QGIS, and I found a plugin for it that'll bring up the extra window that we need, but it needs to be reprogrammed a little bit to make it to our specifications. I've looked into it. Other programs have developed similar things, but they're kind of more like just a screen share. So I'm hoping that we'll be able to do this fairly easily.
Okay, thank you. So this is where we are with the realization of this, I would say, modern interpretoscope. But now, let me please to continue with what actually kind of innovation in human-computer interaction technologies we can apply to resolve tasks like that. So what these technologies are, but not limited to, it's voice recognition, it's eye gaze tracking, it's gesture devices, haptic devices, and finally, we have, if you look on Justin, he has very beautiful helmet on himself, which is electroencephalogram of brain, or EEG device. So right now we started, again, it doesn't matter for collaborative environment which type of interface we use. It could be two trackballs, it could be two whatever. But for us it's interesting kind of mind control, which we call EEG. And at this point I will pass drive to Justin and he will do some demo of how we can use the EEG device to control specifically photo mode application. Justin, please start from test bench. Go ahead with it. So now you can see Justin has electrodes on himself, and when he smiles, right, you can see here signals of his brain which are happening during his smile. You can see him also on video, right, what he's doing. Yeah. Yeah, do something. Yeah. So he is smiling. Okay, so from this 16 signals, you can recognize that something happening in brain when somebody is doing command, right? Okay, please switch to emotive series. Not emotive. Yeah, put it somewhere, they will see it. Resolution is not so good. Yeah. Okay, at least try something. So now you can see his avatar repeating his facial reactions. So enough. And finally on business, let's see how we can teach let's say photogrammetry. Let's switch to photo mode. So here tell us what you did.
And what I did with this program is, or this headset is they give you a software SDK for it, where you can write applications in C# or C++. And what I did was write an application that first interfaced with Google Earth to do simple zooming in and zooming out, and where you could control the mouse pointer with the gyroscope that is included on the device. And then I moved into using PhotoMod, where it's set to change the parallax of the image that you're looking at, or your stereo pair, and I will show you a demonstration of that right now.
Okay, so
yes.
you have to to be true. Yeah. So now we can see how we can control height of sort of photo mode by means of Justin's brain, right? By means of his facial reactions.
Yes.
Okay, so this works. Thank you, Justin.
Yes.
Okay, let's continue our discussion. Okay, I don't need calculator. I went back to my presentation. Oh. Where is this full screen? Yeah. So now let me briefly to discuss our future research plans and continuing of this research. So first of all, we have to estimate this new way of photogrammetric measurements, and unfortunately my collaborator, Dr. Chumin Gao, he has a lecture right now. We're at university, and he will present it better than me, but actually our testing plan is like that. First of all, we want to research accuracy. So how accurate is measurements with EEG, hands-free control? I'm responding to Dr. Reisman's question, what means hands-free? It means by power, it means control by EEG. And secondly, we want to compare productivity. So how fast is to actually to control, if you want to measure 50 points, it will be faster to measure traditional way or this way. And what is really important, we are looking on some data sets, basically a comparison database, actually from professional photogrammetric operator to see, basically HCI, we also have to consider some experienced and non-experienced operators, etc. So this part is HCI research. Another part, basically with this technology, we may think about having, let's say, student and teacher or some analysts collaborating via internet. So to this end, we may have this cognitive control in different, let's say, computers, which could be in different parts of the world. And we even may have some analysts with smartphones, iPads, and all these kinds of operations, which will use the same API and actually to share visual thinking, visual logic of people from in other parts of the world. And this is very well fits with ideology of cloud. So basic operations which are automated can be distributed to the point cloud. And via internet, we can do this communication. So we may have this interpretoscope, but global interpretoscope, when to any photogrammetric operator, so analysts will be able to communicate each other. And Joachim, you won't be surprised, this is your next project. After open water will be done. And Krishna probably will be willing to visualize it somehow, right? Okay, so it's network deployment. Secondly, we are thinking of implementing more sensors for example, eye tracking, because eye tracking can easily catch up attention. So because our attention is expressed in basically fixation zones. But a combination of EEG and eye tracking is winning because we know very famous Midas effect of eye tracking, and this is story of everything what you touch will become a girl. So. But EEG is actually conscious command and not subconscious command of eye tracking. What we plan to implement is, and here you can see basic elements of physiological gaze trajectory of the human eye. And we know that here it was attention. Here, analyst was thinking about anything. And we plan to build some inexpensive, actually major problem with eye tracking in my experience, we have two systems here which are no cheaper than $26,000 each. For simple reason, they're used by medical doctors in oculography. And definitely it's not what photogrammetric operators will afford. However, if you can see here a link to the under $50 device eye tracking, it can be combined and it can expand this kind of interfaces. In conclusion, actually, we foresee the following challenges in this research. So we should not disturb analyst or operator regular workflow. So if this will It should increase productivity and not decrease productivity, even if it's collaborative. And second, and finally, we should be interoperable with state-of-the-art system. Basically, to build this kind of environments, God forbidden for us to build our own. So we have to use photomod, we have to use other systems, right? And just to do kind of plugins to these systems. And finally, we would like to express our gratitude to Rakurs and personally Dr. Radrov, who supported this research and provided us with photomod light software license. And we hope to get also test data sets from photomod and some materials which will help us to really succeed in this. Thank you very much. We are ready to get some questions. There we go.
Оригинальное выступление.
Very original, I can say, in the best style of Eugene Levin. Can we ask questions at all? Is there a connection? Are there questions from the room? Are there questions? I think it would be great time to thank them for the job well done. What do you say? Yeah, we can see you now. Can you see me, Eugene? Yes, I can see you. Thank you very much for your presentation. It was fun to listen to. Возможно, на английском лучше с тобой.
That's why. Yeah, please talk English.
Thank you very much for your presentation. It was quite interesting, and I hope very much that together we will organize more interesting, more usage for such modern technologies, and also I promise to support these investigations from our company. Thank you.
Thank you very much.